I'm going to teach you right now how the charge circuit on laptop motherboard works. So let's get started. So guys, I'm going to teach you the short circuit here theoretically, and also we're gonna see the motherboard, not just the motherboard, we're gonna see this motherboard and other motherboards. So I will make it easy for you guys. This is the only video you need to understand 100% the charge circuit and how it works. So we're gonna see the theory part and also the practical part. Okay, my friends, for the practical part, I'm going to teach you the component near to the battery connector, what is its purpose, how to test it, the voltage here, and the most failed component, and how to resolve charging issues, etc. But let's first see the theory parts. So basically, my friend, we have the IC in the middle. Let's name it this IC charge IC. Okay, here basically we have the charging port. In this side, my friends, we have the power jack, or let's see the charging port. Okay, the charging port basically has many pins. Let's see here connected to the ground, and we have the high pin here. This high pin basically, my friends, is connected. Sometimes it could be connected to a fuse, okay, but sometimes it could be connected to inductor, or sometimes we can find diode, protection diode like this. Okay, my friends, but let's see a fuse. After that, of course, we have the switch. Depending on the type of motherboard, we can find, this is basically Q or switch, the first switch, or we can call it also FIT. The first switch basically, usually we find in channel switch. Here we have drain, here we have source, and over here we have the gate. So for some motherboard, we can find just one switch, but for others, we can find basically two switches. Okay, we can find basically, my friend, two switches. The second switch here. Please pay attention. We're gonna see this here theory in the theory, and we're gonna see the motherboard also. So we have the switch basically here for in channel. As I told you, it could be the N channel used here or P channel, but usually we use N channel. Okay, this is for the switch. The switch basically, my friend, is always connected to a current sense resistor. Okay, we called it current sense resistor, or simply CSR, current sense resistor, or current sensing resistor. Okay, after that we will get what we need. So we will get here B plus. Okay, this is B plus. This is the main voltage, the most important voltage that is used to power the whole motherboard. Okay, just please stay tuned. Okay, so in this side, so here we have the power adapter. Here basically, let's say one of the most component, or the important component in charge circuit, this one, the charge IC. And in this side we have what? We have basically the battery connector. Let's see like this. We have overhead the battery connector. Okay, this is BAT connector, or CN. Okay, this is the battery connector, my friends. Okay, so now we get the P plus. My friends, we're gonna see all this in the motherboard. Just stay tuned, be patient, and we're gonna see everything. After that, we need here for the charge IC, we need here two MOSFETs, do basically the higher MOSFET of or high fit. Let's call it high fit this time, or high MOSFET, and we need another lower MOSFET or low fit. Okay, my friends. Here basically for this one, this MOSFET, its drain, okay, the drain for this MOSFET is basically connected to what? Connected to, always or usually we find ceramic capacitors here for filtering purposes, connected to the ground, and this one connected to B plus here. But let's see, here we have extension, here we have B plus, basically the same as this one. And of course the source here of this one will be connected to the drain of this MOSFET. Okay, the gate here will be connected to the IC, okay, because this is the control IC. For this MOSFET, the source will be connected to the ground, and the gate also will be connected to the IC. Here we have lower, here we have the higher gate. Good. This one we have Q1, we have Q2, we have here Q3, here Q4. Nice. So guys, here of course, connected to the IC, here we need inductor, coil for filtering. We need coil of course, and of course we need also a current sense, another current sense resistor for the battery, okay, another C current sense or sensor resistor, and of course we will need here some capacitors. Sometimes we can find, of course, ceramic capacitors, not polarized capacitors. Sometimes we can find polarized capacitors. And then, of course, we will get what? My friends, we will get, let's make it like this. We will get B or BAT plus. Okay, we will get BAT plus, or the voltage for the battery. Okay, good. But we need something else, is the MOSFET, the battery FET or MOSFET Q5. This one basically is connected to the battery, okay? It is connected, of course, to the battery here, okay? And this one basically is used, let's see, here we have source, okay? And of course, we have the gate. The gate, of course, this one also is controlled by the charge IC. And this one, guys, also the drain of this IC is also connected to this line or power line or power rail B plus. Because when the adapter is removed, this is the battery will feed the motherboard. It will generate B plus. Okay, we have power jack, we have the fuse for protection. We have here basically the two MOSFETs. I told you in some motherboards you can find just one switch. We have the CSR or current sense resistor or current sensor resistor. It basically measures this. This basically current sense resistor is connected to the IC, my friends. It is connected to the IC here. It senses and measures the amount of voltage consumed by the whole motherboard. Also in the next to the battery connector we have the CSR. I can even show to you, my friends, these two current sense resistors in the motherboard. Sometimes we find, okay, sometimes we find R010 or R020. Let's see the motherboard, guys. You see, my friends? Let's take this one, for example. Okay. You see, my friend? Here we have the current sense resistor. We have the second one. The big one, always the big one, is for the motherboard. Here, the big one connected to the power jack. Here we have the power jack, we have the switch. Okay? And this switch is for the battery. This switch is for the power jack. This CSR, current sense resistor, measure the whole current consumed by the motherboard, and this one is for the battery. Also we have here R020, and of course to test it, for beginners, to test it you have to find about 1 ohm or 2 ohm. We can even test it, no problem, just for beginner. Let's put the multimeter, okay, the multimeter to ohm option. Let's select 200. Okay, my friends, 200 here, and then check these two current resistors just to master testing. Okay, let's check. I have the multimeter, one probe here in this side, the other probe in this side. We get to 1.5. Do you see, guys? Okay, 1. Let's check this one also. One probe here. Okay, one probe in this side, the other probe in this side. We get to 1.5, 1, 2, no problem. Okay, my friends. So these two consensus are good. But if you get one like this in the multimeter, means these consensus resistors are open. You have to replace it. If the current, guys, pay attention, if the current sense resistor is open, the motherboard will be dead motherboard. Okay, and also in many cases, my friends, the charging issue when the battery is not charging due to the current sense resistor. To open the current sense resistor, of course, it is reliable, and it doesn't fail a lot, but sometimes if it fails, the battery will not charge, and also no charging battery, and also dead board. When you use the battery, the motherboard will need to be powered because of this current sense resistor. So I hope that you understand. So if you understand the working principle, that's it, no problem. You didn't want to understand the same board, just the working principle. Something is hot here. What you have here, my friend, the first here is the charge IC. Here in the back, we have the charge IC. Okay, my friend, here in the back, we have here the charge IC. So always attention to the charge IC, because this one could be the failure. The charge IC. Exactly as I have here. The charge IC first. Then MOSFETs, especially this MOSFET that is connected to the ground, could be failed. So here basically we have MOSFETs. We have this one and this one. Okay? Do you see the current sense resistor, the CSR? This one? This no, it will not be failed. This one will not be failed. Okay? And you have these capacitors here. Attention to this capacitor. Do you see his thermal capacitors? Those capacitors here, one of them could be shorted. Those could be shorted. Those are inductor basically. Let's see another motherboard just to understand. Same, my friend, but please pay attention. Here, also, this MOSFET could be failed. But this MOSFET, if it's failed, this MOSFET basically is not connected to the short. This MOSFET is not connected to the ground. So this one is excluded. Here, always you have to check component connected to the ground. And what is the component connected to the ground? Those, my friend, the capacitors connected to the ground. Okay, This no, this good, nothing here. This one connected to the ground. This one also could be failed, yes, if these two could be failed in the same time. And this one is connected to the ground. Always the IC connected to the ground in many pins. So IC, MOSFET, capacitors. Okay, my friend? Or if you have here, if here you have a bad connector or a shorted connector. Here, for example, let's see this one here. Okay. We have a battery connector over here. We have the battery connector. Do you see the battery connector? We have the two switches here. The two switches, and we have here B+. This is the input. Okay? Two switches. These switches could be failed. We have the charge IC could be failed. And in this side, we have a protection diode. This one could be failed here. This one also could be failed. And serum capacitors here in the output could be failed. So this is it, my friend. Easy. So check charge IC, MOSFET, serum capacitors. Charge IC, MOSFET, serum capacitor. That's it. And of course, in the output also could be failed. Those also, if shorted, you will get something hot next to the battery connector. We have the input, 3 serum capacitors. We have 2 MOSFETs, we have coil. 3 serum capacitor in the input, MOSFETs, coil, we will get output. We have the IC, okay? We have the IC here, okay? So this IC will generate, basically we have the coil, and here we will get 3.3 volts. Here we will get 3.3 volts always, okay? Here also we have inductor, and here basically we will get, okay, 5 volts always. Okay, we have inductor here. Let's see, L1, L2, and that after that, of course, let's deal first with the output. In the output, we have, you can find serum capacitor. We can find an electrolytic capacitor connected to the ground here. This is for filtering. Okay, we have inductor. We have here 2 MOSFETs, Q1. We have here Q2. Basically, Q1, my friends, the drain is always connected to 3 serum capacitors here, and those connected to what? Connected to B+, my friend, B+, the main voltage, and here connected to the ground, the same as we have here, my friends. Do you see? Do you see here, my friends? We have 3 serum capacitors. Okay. What we will draw right now, my friends, based on one comment of one of my followers, just by taking a look to the motherboard. Easy. We will begin with 3 volt, 5 volt. We will see also how to draw RAM circuit, CPU circuit, or circuit. So I will just look to the motherboard. What we have here? We have the input, 3 serum capacitors. We have 2 MOSFETs. We have coil. 3 serum capacitor in the input, MOSFETs, coil. We will get output. And we have in the output, we have electrolytic capacitor here. And of course, we have the IC. Nice. So let's continue. So 3 serum capacitors, my friend, in the input, okay, and of course the source of this one will be connected to the drain of this MOSFET, and then the source of this MOSFET will be connected to the ground. These 2 MOSFETs basically are controlled by this IC. We called it the 3 volt, 5 volt control IC. Okay, so here, my friend, the B+, basically it's say 19 volt, will pass through this serum capacitor in order to be filtered, and then will be present here in the MOSFET. So here 19 volt, here we will get, here my friend, we will get 3.3 volt. Why here we have 19 volt and here we will get 3.3 volt? Why? Because of this control signal. This is the controller that controls the MOSFET. Okay, my friends? The same, and of course after that the 3.3 volt will pass through this inductor here. Basically these 2 components, the coil and the inductor, are here for filtering, to filter 3.3 volt in order to get here a pure and exact 3.3 volt in this side. The same, my friends, the same for 5 volt circuit. We have the IC, we have two MOSFETs or two switches basically. So Q1, Q2, Q3 and Q4. The drain also will be connected to 3 ceramic capacitors. As you can see, 3 ceramic capacitors connected to the ground. Here, of course, here we have B plus, the same input basically, my friends, 19 volts. And these two B plus, my friends, coming from where? Coming from, do you remember when I told you that we have two switches in the input and then we have the current sense resistor or CSR, current sense resistor, and here we will get B plus, and I told you that this B plus will be distributed to all circuits. Yes, this is it, my friend, distributed to all circuits. Okay, so this B plus, if for example in the 3 volt 5 volt circuit you didn't find here B plus 19 volt, you should go here and check current sense resistor, is it good or not. Check the MOSFETs until the adapter or the power jack. Okay, nice. So the source of this one, my friend, will be connected to the drain of this MOSFET, and then the source of this MOSFET will be connected to the ground. The two MOSFETs also are controlled by the charge IC. So the same 19 volt, my friends, will pass through these ceramic capacitors to be filtered, and then will be present here, will be applied to this MOSFET. We will get here 5 volt. Why, my friends? Here we have 19 volt, here we get 5 volt. Why? How this is happen? Because of the IC, because of this control signal. Here, for example, we have water, a lot of water. Enter here, a lot of water, my friends. Okay, but here we get just a little bit water here. So here, this lot of water is 19 volts. Here, basically, this is the gate. And here we will get 3.3 volt. Okay, we have 19 volts, the same 19 volts. We get here 3.3 volt because we use this gate here. This is the gate. If we turn this one a little bit, we will get 5 volt. If we made another turn, we will get 8 volt, for example. Another turn, we will get 12 volt. If we turn it until maximum, we will get 19 volts. Okay, this 19 volt will be also here, but just a little bit, we get 3.3 volt. This same working principle used with 3.3 volt IC. For this motherboard, we have the CPU. We have two coils, the first channel, the second channel. This one is VCCP, not for VCCORE. Those are for VCCORE. We have two MOSFETs, here two MOSFETs. So for each channel, coil, two MOSFETs, coil, two MOSFETs. In the other side, ceramic capacitor in the input, ceramic capacitor in the input, and in the output we have 10 ceramic capacitors, or it could be electrolytic capacitor. So let's see right now the CPU circuit. Remember, please remember the component. Let's see even another motherboard, always the same. We have the CPU, two coil, MOSFET, two MOSFET for this channel, two MOSFET for this channel. We have ceramic capacitor in the input, and if we go back for this, basically for this CPU, we have 4 MOSFETs, as you can see. 2 MOSFETs here and 2 MOSFETs in the back. 2 MOSFETs here, so 4 MOSFETs for each channel, and we have the IC, and we have 10 ohm capacitors here. 10 ohm capacitors in the output. Let's draw it right now, my friends. Basically, I will draw for you a simple CPU circuit with 2 MOSFETs. Okay, and another CPU circuit with 4 MOSFETs like this one. 4 here, and we have 4 here. Okay, CPU circuit. Okay, For the CPU circuit, guys, attention please. This is the most complex channel in the motherboard. That's why it deserves your attention. The most complex chart in the motherboard, it deserves your attention. Okay. We have here the CPU IC. CPU IC. Okay. The CPU IC. Nice. Normally here we have one channel. Let's make like this. We have here one channel, my friend. Okay. To get here what? To get here the plus VCORE. This is the first channel. And over here we have another channel. Let's structure first the channel. To get what? To get the same voltage plus VCORE. Basically the two channels are connected, my friends, two channels. But here we don't have just IC like 3 volt, 5 volt circuit. No, my friends, we have also here the CPU itself. The CPU itself. Okay. Why we have the CPU here, my friends? We have the CPU because each CPU have an exact voltage, a voltage, let's see, reference. Each CPU has an exact voltage. So the CPU always send, we called it IDs, CPU IDs, about 7 or 8 signals like this, 1, 2, 3, 4, 5, 6, 7, 8. The CPU sends the signals to the CPU IC, and based on the CPU IDs, the CPU IC, we know that, for example, the CPU is powered by 1 volt. This CPU, but another CPU, it could be 1.1, and basically the range is between 0.7 volts, okay, for VCC, let's say like this, to 1.2 volts. Let's see here, we have here what? We have plus VCORE, guys. Okay, so for this CPU, for example, plus 1 volt within the range. Good. So once the CPU IC receive this identification signals from the CPU, it will then generate the VCORE. But we need here, guys, we have two channels. We need here basically the first MOSFET, Q1, the second MOSFET, Q2 for this channel. Okay, this MOSFET basically connected to certain capacitors. Basically we can find just 3 here or more, and those connected to the ground. And here we have what? We have B plus. Always the hero here is B plus, my friend. The hero voltage is B plus, always B plus, the input. So here we have the input. So then here the source here will be connected to what? To the drain of this MOSFET. And then this MOSFET, its source will be connected to the ground. And here we have gates. Here we have basically the gate, it will be controlled. And this one also will be controlled with this IC. This is for first, basically, channel. And of course here we have basically, guys, we called it phase. I will teach you the meaning of this phase. Okay, this is for the channel. Here, of course, we have, as we have seen in the motherboard, it could be many capacitors, many polarized capacitors, not just one. It could be 2, it could be 3, etc. Always connected to the ground. For the first channel, the same working principle. We have Q3, we have here Q4, okay? So the drain of this MOSFET should be connected to what? To what, my friend? To the same B plus, okay? To the same B plus here. And then its source, okay, will be connected to the drain of this MOSFET, and then the source of this MOSFET will be connected to the ground. And then, of course, here, as you can see, this one will be connected to the IC. And this MOSFET basically also will be what? Will be controlled by the same IC, as you can see, my friends. This one also we have here L1 first channel, L2 second channel. Here basically, my friend, also we have ceramic, or this is basically tantalum capacitor or electrolytic capacitor connected to the ground. Okay, so this is the first channel, and this is the first channel, this is the second channel. The purpose is to generate plus VCC core. This is the purpose. So this is a simple CPU circuit. Okay, guys, let's draw a very complex CPU circuit, very complex one. Okay, so please hit the like button. I need more likes to draw for you the most complex CPU circuit that you can find in motherboards. Very complex, and I will show you, even if it's complex, I will show you how to deal with it and what is the most failed component in it. Let's draw it right now, my friends. The most complex CPU circuit that you can find ever. This is a simple CPU circuit. Let's draw a very complex CPU circuit, very complex one. I need more likes to draw for you the most complex CPU circuit that you can find in motherboards. Very complex, and I will show you, even if it's complex, I will show you how to deal with it and what is the most failed component in it. We have here the CPU. I will a little bit make here things smaller. We have the CPU. Okay, my friends, and here we have the IC. CPU, IC. And over here, we have driver. We called it driver. This driver is a small IC. This driver is not like this IC, but a small IC. I will show you this kind of driver in the motherboard. Here we have the second driver. For this driver belong to the first channel. For this driver, it has basically 4 MOSFETs. Not 2, 4 MOSFETs. For this driver also, it has 4 MOSFETs. This is the most complex channel, CPU channel that you can find. And of course, I will check the motherboards here and show you this kind of channels. Okay, so, and of course, here we have, let's see, here we have inductor. Okay, okay, here we're gonna connect everything. Don't worry, my friends. Plus VCC core. This is what we want to generate. Here also we have inductor like this in order to generate the same voltage plus VCC core. Good. So the CPU will send IDs like those. Will send CPU IDs, my friends, about 8 IDs. We call it CPU IDs or VIDs. Okay, my friends? Based on this ID, let's say the CPU is powered by 0.9 volts. Okay? Within the range. 0.9 volts within the range, my friends. Good. I will show you these IDs on motherboards. Please, before continue drawing this schematic, let me grab a motherboard and show you the IDs in order to be sure and to understand, and of course the proof. What is the proof? I will show you the proof, my friend. Now I will show you the proof. Give me just 1 minute to look for a motherboard where IDs are clear. You see, my friends, here this is CPU circuit. Basically this CPU, even if it is old, Guys, please, even if the motherboard is old, but the same working principle. You can check your motherboard, you will find ID. This is the CPU circuit. If I go here to the back, okay, this is the back of the CPU circuit. Do you see, my friends? Check here, my friends. Do you see here? Okay. The problem, the zoom out and in problem. Let's do like this. Okay. This is the CPU circuit, my friends. This is the MOSFET tantalum. This is the tantalum capacitor in the output. Here I have the CPU circuit. Do you see, guys, here? Do you see those test points? We have 1, 2, 3, 4, 5, 6. Okay, we have 7, 8, 9, 10, 11. Because this point is not connected to this. You see the trace here, go here. So those basically, my friends, are IDs. Those basically are coming from the CPU. The IC receive those IDs in order to generate here. This is the input, this is the output. It receives this ID exactly as those. Like those, my friend, in order to generate VCORE. I hope that you understand. I'm sure you understand. Please, my friends, just 1 minute. Did you ever watch like this kind of videos, or this is the first time? Let's first continue and completing this very complex schematic. So here we have drivers. So this driver basically are connected to the IC. So the IC here control the driver, and then the driver control those MOSFET. Okay, the same gate. And of course those MOSFET, the drain here, as you can see, all drains here are connected, and here you can find many ceramic capacitors like this. And here we have what? We have the B plus here. Here, my friend, we have the B plus. So the B plus will be applied to these capacitors that are connected to the ground, and then applied to this MOSFET Q1, Q2, and the source of this MOSFET will be connected to the drain of this MOSFET. The source of this MOSFET will be connected to the drain of this MOSFET here, and then this MOSFET will be connected to the ground, and of course the source of this MOSFET also will be connected to the ground. Q3, and here we have Q4. And of course here we will get, my friend, here of course always connected to the IC in order to correct the voltage. Here we have L, here we have capacitors. Okay, basically it could be 3, 4, etc. connected to the ground. The same, this is the first channel, my friend. For the second channel, the driver also will be controlled by the IC, and the driver also will control this MOSFET and this MOSFET, and also control this MOSFET and this MOSFET. The drain of this MOSFET is connected with the drain of this MOSFET, and then connected to what? Connected to the B plus, always B plus, the main voltage. This B plus basically, my friend, is coming from where? Is coming from the current sense resistor, the CSR. Okay, coming from the current sense resistor and divided to all circuits in the motherboard. Okay. So we have here Q5 and Q6. The source of this one will be connected to the drain of this one, and then the source of this one will be connected to the ground. The source of this one will be connected to the drain of this one, and then the source of this one connected to the ground. Here we have Q7 and Q8. And of course, we will get here, we have here basically the, let's say L1, L2, L3, L4. Here, of course, we have tantalum capacitor connected to the ground, and then we will get plus VCORE. So this is basically, this one is basic, is normal. This one is a little bit complex. the failure here is easy, simplified. It could be IC, MOSFETs, or capacitors, or serum capacitors in the input. Okay, but this one we have driver, we have more other MOSFETs. This basically here, 4 MOSFETs here and 4 MOSFET here is the same, my friends, is the same as this one here. We have 4 MOSFETs. Also we have here 4 MOSFETs and 4 tantalum capacitors. So here we have B plus, basically 19 volt. It will pass through, okay, 19 volt, pass through these ceramic capacitors to be filtered. It will be applied here to this MOSFETs. The MOSFETs, basically the CPU will control the driver. The driver will control this, guys. Basically this driver, guys, is used here just to make things very accurate, because for the CPU always we have more components. Why? Because we need a very pure exact voltage, 100% exact voltage for the CPU. So here we have 19 volts. Those MOSFETs will be basically controlled by the driver and the IC to get here how much? 0.9 volt. Here we got 0.9 volt. Why? Using the faucet rule. Using the faucet rule, my friend. A lot of water, we get here, we have 19 volt, we get here 0.9 volt. 0.9 volt. Faucet rule, my friends, or the tap. Okay? And then here 0.9 volt will pass through coil with capacitor for filtering. And then we will get VCORE. We have another channel. The first channel here, and here we have the second channel. Why basically we have more channel? Just in order, this channel works, for example, for 3 milliseconds, this one works 3 milliseconds, and switching work. Okay, it's a shift work, because all the CPU needs a consistent voltage. That's why we have more channels. For the RAM circuit, we have the IC. Okay, we have IC, RAM IC. Easy, it will receive basically the inputs, and the output will be applied to basically 2 MOSFETs. Okay, Q, the same working principle. This MOSFET will be connected to what? It will be connected to B plus, sometimes to B plus, sometimes to 3.3 volt, and sometimes to 5 volt, depending on type of the laptop. Okay, my friends? Of course, here always we have ceramic capacitors connected to ground in the input, the source connected to the drain, the source connected to the ground. Here controlled by the IC. Okay. So here we will get the voltage. The voltage here for the RAM, the VRAM, depending on the type of the RAM. If the RAM is DDR5, the voltage will be 1.1 volt. If the RAM is DDR4, the voltage will be 1.2 volt. If the RAM is DDR3, the voltage will be 1.5 volts. If the RAM is DDR4, the voltage will be 1.8 volts. And let's see DDR5, DDR5, DDR4, DDR3, DDR2, and DDR1, 2.5 volt. Not use it. Use it a little bit. Use it. This is the used one, DDR5. Okay. So here, depending on type of the RAM, we will get here plus VRAM. If we say the RAM is, for example, DDR5, we will get here how much? 1.1 volt for the RAM. Of course, here also we have capacitors, electrolytic capacitors for filtering and inductor. But for the RAM, This voltage, basically 1.1 volts, okay, 1.1 volts here, this one, my friend, will be applied to another IC, we called it divider. In order to get what? To get the half, divider, divided by 2, and then we will get 0.55 volt for VTT. Okay, my friends? Sometimes we can find two IC, but sometimes we can find the same IC generate 1.8 volt and generate also the VTT divided by 2. I hope that you understand, my friends. I hope you understand. We have basically discussing 3 schematic: RAM circuit, CPU circuit, and charge circuit, and also 3 volt, 5 volt circuit. Please, more likes for the video.